Hello everybody, me again. I just want to refresh your memory on some terms that we might be coming across that we might have forgotten about. Squares, cubes and primes, or squares, primes and cubes. So to start with, let's start with square numbers. Square numbers are numbers that are the answer or the result or the product of a number that has been multiplied by itself. So for example, let's start with 1. Okay, when we times 1 by itself, we end up with 1. 1 is a square number, okay? What we are essentially showing here is that we have square of 1 by 1, length times width, okay? 2 times 2, okay? 4 is a square number, and the square root of 4 is 2. We can keep going on. Okay, 9 is a squared number, and it shows me that I have multiplied 3 by itself. Okay, so in year 6, we should know the square number pattern almost as well as we know how to count in 2s and 4s and 6s and all our times tables. 1, 4, 9, 16, 25, 36, 49, 64. We're up to 64, 9 times 9, 81, and then 10 times 10, 100. Really useful counting pattern to know. Okay, the square number is the result. The square root is the number that has been squared. Sometimes you see that. If I asked you for the square root of 9, you would give me 3. You might see that symbol when you get to secondary school. Okay, so they're square numbers. Cube numbers, okay. If we're thinking about a cube, a square, we've got 2 dimensions there, which is why we're multiplying it twice. A cubed number is when we're thinking about that 3rd dimension, when we've got a length times a width times a height. So a cube number is where we are looking at a number times it by a number to the power of 3. So 1 squared, I should have written 1 squared up there. 1 squared would be 1 times 1. 1 cubed would be 1 times 1 times 1. But actually, because it's 1, the answer is still 1. So let's have a look at 2. 2 cubed, or 2 to the power of 3. We're doing 2 times 2 times 2. It's not 2 times 3. It's very different from 2 times 3. You'll see why. 2 times 2 is 4, and we're going to multiply that 2, and then we're getting an answer of 8. So let's have a go at 3 cubed, where we're doing 3 times 3 times 3. Okay, whichever way we do it, I like to do brackets first. 9 times 3 equals 27. That is the next number in my sequence there. So you can keep going there. Square numbers to the power of 2. Okay, and you'll see that little 2 above. Cube numbers to the power of 3. It doesn't mean that if you have a number to the power of 4, okay, so 2 to the power of 4, you're doing exactly the same thing. It's more of a secondary school skill this, but 2 times 2 times 2 times 2 is how we would work that out. Okay, and whatever we're doing is we are following the order of operations, and we're going to end up with 16. Okay, you don't need to worry about that just yet, but just in case, now that you know what that little symbol means. The other thing that we're going to have a little bit of a revision on, prime numbers. So we talk about primes in relationship to factors and multiples. And factors and multiples are the result of any number that has been multiplied by another number. Multiples are the answers. Factors are the numbers that were multiplied together. So when we think about numbers in the 2 times tables, we know that the sequence there goes 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, and so on. All of these numbers are multiples, and they're multiples of 2. It's the same for the 3s, 3, 6, 9, and so on. All of those numbers are multiples of 3. A prime number is slightly different. A prime number only ever has 2 factors, and one of them is itself. Excuse the noise downstairs. 1 and itself. Okay, so what is the first prime number? Well, it's 1, isn't it? Because 1 is the only factor is 1 and itself. In fact, is that a prime number? I'll have to check that one. 2 is a prime number because the only way we can make it through multiplication is by doing 2 times 1, 3 times 1, okay? And then we come to 4, okay? Now I can make 4 by doing 1 times 4, okay? I can also make it by squaring the number 2. This number has then 3 factors, okay? I've set it out in a factor bug here, or a factor circle. Okay, normally if I'm doing that, I might put the 2 at the bottom. And that really helps me. If there's no other factors, if it's not in any times table, I know that it is a prime number. If there is, I know it's not. Okay, so what you should know really is all the prime numbers up to 20 at least. And the way we can always test them is to be thinking through our times tables. So those of you with a really good knowledge of your times tables are often quicker to find your primes, which is why this week we're also going to do quite a bit of work on making sure we're fluent with our times tables. Let's test a number like 17. Apart from 2, and 2 is quite a special number because it is the only even prime number. Every other even number is not prime. Because it's even, you can always halve it. You can always divide it by 2. That may not be the only factor, but it is definitely one. So prime numbers apart from 2 tend to be odd. They don't always, we know that there's not a lot of prime numbers that apart from 5 that end in 5 because they're in the 5 times tables. It's the ones like that end in 7 and 9 that you often have to test. So let's have a look at 17. I know that 17 has multiples of 1 and 17. Is there any other timetable that 17 fits into? So what we do is we test. We go through our knowledge and we test. It's not in the 2s, it's not in the 3s, 3, 6, 9, 12, 15, 18. It's not in the 4s, no bother point checking any more even ones. It's not in the 7s, and it's not in the 9s. It's not in the 11s, it's not in the 13s. So I can safely say there that 17 is a prime number, okay? They're easier to recognize because if you know your times tables, you've got that instant knowledge there that 17 doesn't appear in any of them. It's when we get to numbers like 87, 89. Are any of these prime numbers? The way that we're going to test them, the way that I have taught my class to test them is, I know it's not in the 2s, 4s, 6, 8s, 10s times tables. I know that it's not in the 5s. So really it is either going to be in the 3s or the 7s or the 9s. Okay, my 9 times tables are easy to find out. If it's in the 9 times tables, I'm going to add up the digits. And if that ends up in 9, it's in the 9 times table. So none of those two, 8 and 7 is 15 and 1 and 5 is 6. 8 and 9 is 17 and 1 and 8 is 8. Sorry, that doesn't make any sense. 9 and 8 is 17 and 1 and 7 is 8. But I will test these and to see if they're in the 3s or the 7s. And I'll test them by simply dividing by 7. How many 7s go into 8? I get 1. How many 7s go into 17? I get 2, remainder 3. It's not coming out clean. So 87 is not in the 7 times tables. I'm now going to test whether it's in the 3 times tables. How many 3s go into 8? 3, 6, that gives me 2 remainder. Let's have a look at this. 3 goes into 27 9 times. So actually 87 divides by 3, so it is not a prime number. Okay, you might have looked at that and thought, oh yeah, it's got a 7 on the end. But actually it's divisible by 3. So we always should be testing higher numbers in our 3s and in our 7s. Let's check 89. Let's see if 89 is a prime number. So 89 divided by 7. In fact, I know it's not in the 7 times tables because 7 times 12 is 84. That's not going to work. Let's test if it's in the 3s. How many 3s go into 8? We said there were 2 and there were 2 remainder. How many 3s go into 29? We had 3 times 9 is 27, remainder 2. So actually this one doesn't come out clean in the 3s. This one is actually a prime number. So prime numbers only have factors of 1 and themselves. We do need to test the high numbers. Multiples of the result, any number in the times tables is a multiple, and the factors are the two numbers that we multiplied together. X factor, we multiply them together. Cubed numbers to the power of 3, we times the number by itself 3 times. And square numbers, we times the number by itself. Okay, I hope that's okay. A bit of a whistle-stop tour of some of the learning that we practiced over the year. And there are, I think, a few of those to practice this week, definitely, with looking at some primes and cubes. So good luck.